Okie dokie, okie dokie. Now, I'm going to show you how to find the dimension of a more abstract subspace. So here's my U, and remember my strategy is to express this as a column space or a null space. Well, I'm going to do column space. Let's see why. Well, I can take this defining vector here and break it up, or pull it apart, as we would say. Plus C, negative 2, 0, negative 2. So I can write it like that, A, B, C, blah, blah, blah. Okay, so what does U equal? U is this, it's the set of all linear combinations, okay? Or U is, anything in U is a linear combination of these three vectors given here. So U is equal to the span 1, 0, 1, 0, 1, 0, minus 2, 0, minus 2. So I can think of that as a column space, right? Remember, column space is the span of the columns of some matrix. This is call A. This is a column space for A given by these columns. Okay, so the point of this mathy calculation here is that my weird looking U is actually just a column space. So to find its dimension, I just find the dimension of the column space here. So what does that entail? That entails a quick reduction to echelon form. 1, 0, 0, 0, 0. Aha. Aha. So my basis is the first and second columns. Zero, 1, 0. So that means that dim of this column space is 2. But U equals the column space, so dim of U is also just 2. Who knew? Maybe baby blue. Anywho, that is how we do it. If you can take something like this, and it's quite naturally equal to a column space, you have a nice method for finding its dimension. Now, other subspaces are given differently, and it's more natural to express them as null spaces. Here's an example. This is the solution set. That's a weird NN set. The solution set to, well, the system. A plus B plus C equals 0. B minus 2D equals 0. So I can write that as a null space. Why is that? Well, I can write this system. I can write it as a matrix 1, 1, 1, 0, 0, 1, 0, minus 2 times A, B, C, D equals 0 vector. I can write it like that, which tells me that U is the null space of A, where A equals this guy. Okay, that is how a null space works. You have it's the set of solutions to A, X equals 0 vector. All right, so my U, and the basis of U can be found by reducing A. Let's do that. Little squiggle. 1, 1, 1, 0. Nope, no, I don't want to do that. I want to do row 1 minus row 2 to get to reduced echelon form. I need reduced echelon form for the basis of a null space. 1, 0 minus 2, 2. So I get A plus C plus 2D is equal to 0. B minus 2D is 0. Plugging this into my generic vector A, B, C, D, I get minus C minus 2D. 2D, C, D. Hopefully not making any mistakes here, but you can let me know if I'm dropping the ball here. I pull this thing apart. And I get this. So my basis has 2 vectors. B has 2 vectors. Therefore, dim U is 2.